So let's look at the case when we multiply or divide by 10. And this is useful, especially if you're dealing with the SI units, because when you convert from one unit to another, you are just multiplying or divided by a power of 10. So if you multiply 75 by 10, you get 750, which means that you just added 0 to the right. If you have a decimal point in here, all you're doing is moving that decimal 1 unit to the right. If you take 750 multiplied by 10, you get 7,500. And if you multiply 7,500 times 10, you get 75,000. Again, you're just moving that decimal point. You're starting at 75, and you're just moving that decimal point. 5.00. And you're moving that 3 times to the right. So, if you remember exponents, so we can just rewrite this as 75 times 10 times 10 times 10. This can be rewritten as 10 to the power of 3. Now, when we use the calculator, we can evaluate this, and we are going to use a key, and I don't know if it can be seen, the one that has the 2 E's in there. To use a key, what we do is we press second, and then we press the key. So, for example, 75, second E, and in this case 3. That gave us 75,000, which is the same result that we have in here. And again, if I want to have in scientific notation, I will have to move the decimal point 1 unit to the left. So that would be, that means that I will have to multiply instead by the power of 3, I will have to multiply by the power of 4. So again, 7.4, shift E at the power of 4. And again, this is short, the EE, what it means is 10 at the power of. Instead of me having to write 10 at the power with a hat, I'm just using E. I'm just writing the exponent of the 10 because E has base 10. So EE is the base 10. And what I do here, I wrote 7.4, 7.5. Again, 75,000. So I can do the same when I divide a number by 10. So, but instead of moving the decimal point to the right, that decimal point is going to move to the left. And we can see that in here. 785 divided by 10, that's equal to 7.5. 7.5 divided by 10, that's equal to 0.75. 0.75 divided by 10, that's equal to 0.075. So, again, because I divided by 10, I can rewrite it like this. 75 divided by 10 times 10 times 10. Again, using exponents, I can just write it in this form. And if you remember the rules of exponent, that I can write an exponent like this with a negative exponent. With a negative exponent, I can rewrite this in this form. But this will be scientific notation. This will be 75 times 10 at negative 3. So, if I want to rewrite this in scientific notation, then I'm just going to be putting the decimal point here. So I will have to get 75, I have to multiply by 10 to the power of 1. So I will have to rearrange it, and it will be 75 times 10 to the power of negative 2. But let's verify this quantity. So in this quantity, we say that this is going to be equal to this. And again, I'm just going to use a key E. So 75 second E. You'll see the E popping up. And then I will write the exponent negative 3. Negative 3. That's equal to 0.075. And again, that's equal to dividing 75 3 times by 10. So 75 divided by 10. Divided by 10. 10 times 10 times 10. And I have noticed that I put a parenthesis in there, so again 0.75. So in the calculator, this is 75 E negative 3, and that's equal to this. If I want to write in scientific notation, I have to have a decimal in here. So to write this in scientific notation, I have to multiply by 10 to the power of 1, because the decimal point has 1 unit here and then 3 units back, and that would be equal to 7 0.5 10 times 10 to the power of negative 2. Or if I take this one, just move it here, I know that to get this, I just have to move this 1.2 units to the left. I can arrange it this form. The rule for scientific notation is that I can write any number as a coefficient, a, multiplied by 10 at the power of n. And n will be the exponent. A will be a number between 1 and less than 0. A will be a number between 1 and less than 10. So a number like 7.5 is a good number because it's between 1 and it's less than 10. If the number is 10, then I'll have to add one more to the exponent here, and then I will have to shift the decimal point 1 unit to my left. The exponent has to be whole numbers, but you notice that if you are converting a decimal point like this to scientific notation, all you're writing is a negative exponent. If you have a large number like 75,000, the exponent is going to be positive. So this is useful to memorize, so that way if you have to convert numbers from using scientific notation, that's something easy to do. So for now, that's all I got. But this is useful because then using these rules, for example, if I get 85,000, I can rewrite this relatively easy in scientific notation as 8.5. And since I know that it's going to be a positive exponent, so I can write this positive. And all I have to do is count how many times I'm going to multiply 8.5 to get 85,000. So how many times do I have to multiply 8.5 to get to 85,000? That would be, if I multiply one time, I'll get 85. If I multiply 2, 3, 4, so 1, 2, 3, 4, so that will be 4 times. I'll have to multiply 8.5. If I have a different number, so if I have a decimal, say for example 85, again I can record it the same way, 8.5 times 10, and because this is a decimal, I have to think how many times do I have to divide 8.5 by 10 to get this number. So in this case, the decimal point will be here, so 1, 2, 3, 4 times. I have to divide 4 times, and because it is a decimal, the exponent will always be negative, so negative 4 to divide 4 times. 1, 2, 3, 4 to get this number. To divide 8.5 to get this number. So anyway, I hope that this helped you out, and I hope that this video with the calculator is useful. Good luck in your studies.